Hey class, welcome back to math. Today's lesson is exercise 2 in chapter 7, and we are going to learn about how to add and subtract fractions with related denominators. In exercise 1, we learned how to add and subtract fractions with like denominators, and like denominators means denominators that are the same. Today we are going to learn what a related denominator is and how to add fractions and subtract fractions that have related denominators. Before we get into this lesson, let's review what we talked about last time so that we can build upon that lesson and be ready for today. Today I'm going to use some pie graphs and also a line graph to give you some different tools that you can use to help you solve your problem. So let's add 5/8 and 7/8. And again, these have like denominators that are the same. So 5/8 plus 7/8. Well, here to the right, we can see these little pie graphs. And on this right here, this represents 5/8. This pie is equally divided as best as I can into eighths, and there are 5 of them. This is also equally divided into eighths, and there are 7. So what is 5/8 plus 7/8? We add them together. Well, there's 1, 2, 3, 4, 5 from that first fraction, and then we have 7 from the other. 1, 2, 3, 4, 5, 6, 7. So how many total eighths are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 5/8 plus 7/8. Well, the denominator stays the same. We do not add the denominators together. We don't get 16, okay? The denominators stay the same because these are equally divided into eighths. So we add the numerators. 5 plus 7 equals 12. Do we have a whole pie right here? We do. Because the numerator is bigger than the denominator, we know that we have one whole number. Just like here we can see on the right, we have one whole pie, and then how much is left over? There is 4/8. But wait a minute, is 4/8 in its simplest form? I don't think so. What is a common factor between both the numerator and the denominator? What is a common factor between 4 and 8? Those that are saying it? 4. That's right. That is the greatest common factor between both of them. So if we divide the top and bottom by 4, 4/8, 4 divided by 4, a number divided by itself always equals 1. 8 divided by 4 is 2. So 12/8 equals 1 and 4/8, but bring it to its simplest form, 1 and 1/2. All right, now let's do adding and subtracting with a line graph. Now let's subtract fractions with like denominators, and remember to always put it in its simplest form. We're going to be using a line graph. So now we've covered how to use bar models, and now we're covering how to do a line graph. Again, these are tools that you can use to help you solve these problems. So 7/9 taken away from 13/9. Well, let's find 13/9. As we can see, here is our 0, and here is our first whole part. And this whole part is divided into what equal parts? 1, 2, 3, 4, 5, 6, 7, 8, 9. Ninths. So let's find 13/9. Well, this is divided into 9 equal parts. So we know that 1 is also the same as 9/9. 10, 11, 12, and then here is 13/9. Now we want to take away 7/9. So 13/9 minus 7/9 equals what? Let's count back because we're going to take away from 13/9. We take away 1, 2, 3, 4, 5, 6, 7. Now how many ninths are left over? Well, those that know 13 minus 7 equals 6. Those that are still kind of struggling with math, you can count from the left to right. 1, 2, 3, 4, 5, 6. 6. This is divided into what equal parts? Ninths. 6/9. Now 6/9 in its equalist form, or is there a common factor that we can use to divide to make this into its simplest form? Those that are saying it, that's right, it is 3. Good job. So if we divide the numerator and the denominator by 3, 6 divided by 3 equals 2. 9 divided by 3 equals 3. 2/3. 13/9 and 7/9 taken away equals 2/3. All right, so now let's get into how to add and subtract fractions with related denominators. All right, for our first problem to learn how to add or subtract fractions with related denominators, let's look at this problem on the board or on the screen. We have 1/2 liter that is in the grapefruit juice carton, and I put that as green because the carton is green. And there is 1/4 liter in the cup, which is blue, and the cup is blue. This bar model is representing what is left in the carton, and this bar model is representing how much grapefruit juice is in the cup. So how do we add 1/2 liter to 1/4 liter? We've talked about it. Do we add the denominators together? Does 1/2 plus 1/4 equal to 6? No. How do we add 1/2 to 1/4? Well, what if we put the 1/2 and make it to a like denominator? How can we make 1/2 have a like denominator as 1/4? How can we have them have the same denominators? What can we do to 1/2 so that the denominator is now a 4? Those that are saying it, we can multiply the top and the bottom by 2. So 1 times 2 equals 2, and then 2 times 2 equals 4. 2/4 is an equivalent fraction to 1/2. They both equal the same. Well, how do we represent that on our graphs? If we take this 1/2, we can turn it into 2/4. So now this is 2/4 and 1/4. So 2/4 plus 1/4, we don't add the denominators. The denominators stay the same, but the numerators are added. So 2 plus 1 equals 3. 3/4. So if we were to show that, so if we represent that now, we have 3/4. All right, and sorry, I couldn't erase that carton and cup shape, so I know it's a little difficult to see that. But we'll continue to cover this to give you some more examples of how to do this. All right, so let's learn how to subtract fractions with related denominators. So looking at the problem, it says subtract 5/6 and 1/2. And if we look below that, we can see that there are 3 bar models. The first 2 are to help us solve the problem, and the third one would represent our answer. So 5/6. We can see this first bar model is divided into how many equal parts? 6. So let's fill in 5 of these equal parts to represent 5/6. We can see this bar model is divided into halves, 2 equal parts, which are halves, and there's 1/2. Well, we've been learning that we can't add or subtract fractions that don't have like denominators. So how do we get both of these fractions to have like denominators? We can find an equivalent fraction to 1/2 so that the new equivalent fraction has the same denominator as the 5/6. So how can we turn this 1/2 into an equivalent fraction that will give us a like denominator with 6? 2 times what gives us 6? 3. So if we multiply the top, the numerator, and the bottom, the denominator, by 3, we get, well, 2 times 3 equals 6, and 1 times 3 equals 3. 3/6 is an equivalent fraction to 1/2. If we look at our bar model, we can see that we can turn this bottom bar model that is represented in 1/2 into 6's 6 equal parts. And we can see that 3 of them, 3/6's, is also equal to 1/2. So now what is 5/6 minus 3/6? We have 5/6 minus 1/2, which went to now 5/6 minus 3/6 equals, do we subtract the denominators? Do we do 6 minus 6 equals 0? No, the denominators stay the same, but we do subtract the numerators, the top numbers. 5 minus 3 equals 2. The denominators stay the same, 2/6. So let's fill that in. But are we done yet? 2/6, is that the simplest form? Or is there a common factor that we can use to simplify this fraction? Some of you guys are already saying it. These are both even numbers, and we know that all even numbers can be divided by 2. 2 divided by 2, a number divided by itself always equals 1. And then 6 divided by 2, how many groups of 2 can go into 6? 3. 1/3. Here is a group of 2. Here is a group of 2. And here's the third group of 2. And this one is all filled in. 1, 2, 3, 1/3. So that will do it for lesson 2 and chapter 7. If you have any questions or you're struggling, please reach out to me, message me on Canvas. I do have time to have one-on-one lessons or small group lessons, and so I'd be happy to help you all. Glad to be with you. I hope you're enjoying these online activities. It's crazy. We only have 1 more week left of school before our Christmas break, so please be disciplined. Set aside all distractions that are keeping you from doing your schoolwork and finish this quarter strong so that you are on a good path to passing 4th grade. If you do need help, please reach out to me or Mr. Green, and we will be there for you. Have a great day, and either I or Mr. Green will see you in the next video. See you, class.